Hello dear students. In this video I am going to discuss about streaming stored video in detail. We already know for streaming video applications, pre-recorded videos are placed on servers and users send requests to these servers to view the videos on demand. The user may watch the video from beginning to end without interruption, may stop watching the video before it ends, or interact with the video by pausing or repositioning to a future or past scene. Streaming video systems can be classified into three categories. First one, UDP streaming. Second one, HTTP streaming. And third one, adaptive HTTP streaming. The majority of today's systems employ HTTP streaming and adaptive HTTP streaming. A common characteristic of all three forms of video streaming is the extensive use of client-side application buffering to mitigate the effects of varying end-to-end delays and varying amounts of available bandwidth between server and client. First one, UDP streaming. With UDP streaming, the server transmits video at a rate that matches the client's video consumption rate by clocking out the video chunks over UDP at a steady rate. For example, if the video consumption rate is 2 Mbps and each UDP packet carries 8000 bits of video, then the server would transmit one UDP packet into its socket every 4 milliseconds. That is 8000 bits divided by 2 Mbps equals to 4 milliseconds. UDP streaming typically uses a small client-side buffer big enough to hold less than a second of video. And before passing the video chunks to UDP, the server will encapsulate the video chunks within transport packets specially designed for transporting audio and video using the real-time transport protocol, that is RTP, or a similar scheme. In addition to the server to client video stream, the client and server also maintain in parallel a separate control connection over which the client sends commands regarding session state changes, that is pause, resume, reposition, and so on. Although UDP streaming has been employed in many open source systems and proprietary products, it suffers from three significant drawbacks. So first one, due to the unpredictable and varying amount of available bandwidth between server and client, constant state UDP streaming can fail to provide continuous playout. For example, consider the scenario where the video consumption rate is 1 Mbps and the server to client available bandwidth is usually more than 1 Mbps, but every few minutes the available bandwidth drops below 1 Mbps for several seconds. In such a scenario, a UDP streaming system that transmits video at a constant rate of 1 Mbps over RTP and UDP would likely provide a poor user experience with freezing or skipped frames soon after the available bandwidth falls below 1 Mbps. The second drawback of UDP streaming is that it requires a media control server, such as an RTSP server, to process client to server interactivity requests and to track client state. Example, the client's layout points in the video, whether the video is being paused or played, and so on for each ongoing client session. This increases the overall cost and complexity of deploying a large-scale video on-demand system. And the third drawback is that many firewalls are configured to block UDP traffic, preventing the users behind these firewalls from receiving UDP videos. Next one is HTTP streaming, and this HTTP streaming I am going to discuss in the next video. Thank you.